This meeting is being recorded.
Let's take a look at problem 13 from chapter 10. And we're told some information about this antibiotic natural product, this gamma indomycinone, which is shown down here. And this is involved in a halogenation reaction. So we see our Br2, our halogen here. And this is our major product here. And our minor product is a dibrominated product. So we have our minor product here, dibrominated, and we have our major product, which is monobrominated. So we can see that in the chemical formulas given. We see only one bromine in our monobrominated major product. We see two listed in our minor product. So where would these sites be of bromination? So let's look at this molecule and see if we can figure this out. So we know that our hierarchy of radical sites would be that a tertiary would be more stable than a secondary, and a primary would be the least stable radical site. But what about if we have, say, an allylic primary, secondary, or tertiary radical? Those will produce even more stable radical sites, and those would therefore be the sites of bromination. So if we combine an allylic site as being an allylic tertiary, secondary, etc., those would prioritize over just regular tertiary, secondary, etc. So let's see if we can find any of these sites here. So an allylic site would be something like down here, for example. This would be an allylic site that could be brominated, or actually this is rather a benzylic. So let's include that in our determination. So this is a benzylic position, which can proceed through resonance stabilized benzylic radical intermediate steps. So this would be a good site at the benzylic position. We also have up here an allylic position, and this is actually going to be a tertiary allylic position. So this will be our first site of bromination. This would have the lowest bond dissociation energy associated with that CH bond. So we would have bromination occur at that site. Let me erase my allylic designation here. And you can see that since, again, this would be the weakest CH bond, this would be where the radical site is created, and we would have our monobrominated product. So this other site down here of interest, this benzylic radical site, this would be our second site of bromination. So off of this carbon here, a radical site would form, and we would have our dibrominated compound here with these two sites. So again, major product only has the monobromination up top here. The dibrominated product is our minor product.